So now let's go ahead and actually solve an equation. And to do this, we're going to pick out a variable to solve for first, and we're going to solve for the second variable second. So to start off with, let's just solve for x1. So if we solve for x1, we have 7x1 is equal to, we take this 5 over 9, we move it over here to the right, and since we have negative 9, we add 5 over 9 x2, so we have 5 over 9 x2 minus 1, and then since we have 7x1 equals this, we need to divide by 7 on both sides. So we divide by 7 on both sides. That 7 goes away. We divide by 7 on this side. And what you end up getting is you get x1 is equal to 5 over 9 divided by 7, which ends up being 5 over 63 x2 minus 1 divided by 7, which ends up being 1 over 7. So that is the answer for x1 at this point. But we also want to solve for x2. But the interesting thing about x2 is because we have two unknowns and only one equation, we can't get a distinct value for x2. So it is what we call a free value. So we'll let x2 equal to t. So we take that back into consideration for the x1 equals 5 over 63 x2 minus 1 over 7. So what we get for our final answer is x1 is equal to 5 over 63 t minus 1 over 7, and then x2 is equal to t. So that would be the final answer for the solution to this linear equation. And remember that that x2 value is what we call free. So what are some things that we can do in order to check this answer? We're going to go over that now. So if we really want to just kind of be able to take our x1 equals to this equation, while as x2 is equal to this expression, t, what we need to do first is we need to pick a value for t. And you can pick any value. For our purpose, we're going to pick a value that should be easy to work with. So we're going to let t equal to 0. So t equals 0. And so we're going to take the x2 value. x2 is automatically going to equal 0. And then we want to also take that x1 equals 5 over 63t minus 1 over 7. The 5 over 63, because we have 0 here, that'll cancel out. And we'll have x1 is equal to negative 1 over 7. So now that we have that, we have our x1 and x2 values here. We can take them and we can plug them back into the original equation over here, and we should get a resulting value that is negative 1. So let's go ahead and let's do that. So we get 7 times x1 minus 5 over 9 x2 equals to negative 1. So if we take the 7, and for x1 we want to put in negative 1 over 7, and then we want to subtract off 5 over 9 times x2, which is 0, so that goes to 0, cancels itself out, equal to negative 1. And we have negative 1 over 7 times 7, that is negative 1. And we find out that negative 1 does, in fact, equal to negative 1. So that's kind of just an overview of how you can go back and check your answers. What you could also do is you could plug in, for instance, say t is equal to 5 or 6 or 7. If you do that, you should be able to plug it in so you have x2 is equal to one of these values. And then for that corresponding value you get for x2, you can then plug that back in to the equation. And then you can also do the same thing, plug t into the x1 equation, and then take it back into the equation up here with the values you get out for x1 and x2, and you should get out that b value from the left side of that equation. Cool. If there's any questions, feel free to ask me, and we're going to keep rolling and learn more about linear systems coming up next.